Question 3. A precision micrometer is used to determine the thickness of a thin metallic strip. When fully closed, the micrometer shows a zero error of plus 0.04 millimeters, with an uncertainty of plus or minus 0.01 millimeters. A reading with the strip in place gives 1.26 millimeters, with an uncertainty of plus or minus 0.02 millimeters. What is the corrected thickness of the strip? Now, this problem tests our understanding of systematic errors and uncertainty propagation in measurements. So let us begin by recalling what we already know. We know that systematic errors such as zero error shift every measurement by the same amount. Because of this, the zero error must always be removed from the measured reading to obtain the true value. The corrected value is therefore given by true reading equals measured reading minus zero error. Another important idea is that when quantities are added or subtracted, their absolute uncertainties must also be added to obtain the final uncertainty. So final uncertainties of combined quantities, in the case of sums and differences, are determined by adding the absolute uncertainties of the separate measurements. Now let us proceed to the solution. We are given a zero error of plus 0.04 millimeters, with an uncertainty of plus or minus 0.01 millimeters. The measured reading with the strip in place is 1.26 millimeters, with an uncertainty of plus or minus 0.02 millimeters. To find the corrected thickness, we subtract the zero error from the measured reading. So the corrected thickness equals 1.26 millimeters minus 0.04 millimeters. This gives a corrected value of 1.22 millimeters. Next, we determine the uncertainty in this corrected value. The uncertainty in the measured reading is 0.02 millimeters. The uncertainty in the zero error is 0.01 millimeters. Since these quantities are combined through subtraction, their absolute uncertainties are added, so the total uncertainty becomes 0.02 millimeters plus 0.01 millimeters. This gives 0.03 millimeters. So the corrected thickness of the strip is 1.22 millimeters plus or minus 0.03 millimeters. This is our final answer. What did we do? First, we corrected the measurement by subtracting the zero error, because a positive zero error means the instrument reads too high. Then, we calculated the final uncertainty by adding the absolute uncertainties of the measurement and the zero error. Finally, we expressed the corrected result together with its uncertainty. Before we summarize, let us address a few potential misconceptions. Some students might subtract the uncertainties, just like the main values, instead of adding them. We must remember that in uncertainty calculations for sums and differences, absolute uncertainties are always added. Also, some candidates might incorrectly add the measured value to the zero error instead of subtracting it. Now let us finalize with the main takeaways. Corrected thickness is obtained by subtracting the zero error with careful attention to its sign. Also, the final uncertainty combines both the measurement uncertainty and the zero error uncertainty by adding the absolute uncertainties.